Welcome, Brad, to our first DevFest Central Asia online event. Thank you that you are with us. And I would like to introduce our viewers, Brad Morgan, the Google Developer Relation in Sydney, and he's mostly focused on Flutter and Dart languages. So welcome, Brad, and you can start your presentation.
Okay, I'm all queued up. Share my screen. Sweet, thank you. Okay, so I'm hoping everyone can hear me. I'll just click on something up here. Yep, cool. Okay, so null safety in Dart. Help if I click on that window. Cool, I have control now. So firstly, to talk about the elephant in the room, Flutter. Dart is the implementation language for Flutter. But however, right now at the time of recording, you cannot do what I'm about to talk about. You cannot run null safe Dart in Flutter. Hopefully that will change really, really soon now. So if you're watching this on YouTube, check, and it should probably be working. But yes, watch this space. With that said, I want to work through a problem just in straight Dart that happens a fair bit in Flutter. So the Flutter developers in the room will hopefully understand what's going on and go, okay, I can see what the problem is and how null safety helps with that. So let's just flip windows. And okay, it's not, let's get out of that and go and find the right window. There it is. Multi-window systems, they're great fun. Okay, so here's a class. It's going to turn into a value class, so let's go ahead and do that. We've got some values. We're going to have a color. It's going to be made up of red, green, and blue components. They're finals, so we're getting some warning from the editor saying it should probably be initialized. So let's turn around and have a bunch of named initializers. So we'll turn around and have the ability to turn around and define this color in terms of red, green, and blue. Let's have a person who has a favorite color and the ability to print out what that color is, and a main function. So we should be able to just do Dart run. And we can see that I have a favorite color of instance of color. That's not quite the best idea. Let's add some information to color to actually make it possible to understand what's going on. We'll give it a getter for hex that will turn around and dump out the red, green, and blue as a hex value. Okay, color.hex, and we won't go that far yet. We'll turn around and save that to disk. Turn around and run that again. As you can see, my favorite color is 00FF7F, sort of greenish blue. Okay, cool. What happens if I turn around and I don't have a favorite color? Turn around and run that, and we get this horrible looking stack trace. It might just give us a little bit more space here so we can see what's going on. So getter hex was called on null. So it's about here somewhere. We can click on this and we can see exactly there. That's not good. And in fact, it's worse than that. This is also the same. If I don't set a favorite color, then boom, we're going to hit a null pointer exception. And if you go and have a look on GitHub and do a search for null pointer exceptions and have a look at all the people who've had to turn around and add special casing for nulls in various parts of their code, it's a fairly common pattern. So let's start fixing this. Let's turn around and if the favorite is null, then the person obviously has no favorite color. That should fix it, right? Okay, I'm a person with no favorite color. That's good. But I can be a little bit worse than that. I can turn around and, I don't know, be a person that likes purple. I have a red and a blue, but I haven't set a green component. And I turn around and run this code, and no such method was called. What? What's going on here? I can even look in the stack trace and go, oh dear. This is obviously, I'm breaking the contract of this color class, but it's not in a way of, let's just hide that off screen. We've broken the contract of hex encoder, or moreover, of color. So how can we turn around and start pulling this in? So what we can do is we have a package meta, which means we can turn around and say all three of these attributes of color are required. And if we squiggle down here, we can see color is now giving us a warning saying the parameter green is required. But I can go further than that. I can set green to null and the warning goes away. And would you believe we still get the same stack trace? So what else can we do? Well, what we can do is we can turn around and have a bunch of assertions and really go to town on actually enforcing the fact that these things shouldn't be null. And if I go down here and run this again, we can, no change. What you have to do to take advantage of asserts is run with asserts enabled. And if we do that, we suddenly see that unhandled exception, failed green is not now. We finally have at runtime the knowledge that we're breaking the contract of color. We've gone to a lot of work here. We've done a lot of messing about with the definition of color to try and enforce the fact that we don't want red, green, or blue to be null, but we haven't drawn that in. So the language is kind of failing us here. Okay, let's go back to the presentation and think about this. I'll just scoot this off screen, go back to presenting. So I've just run you through the problem. Let's look at it in detail. We've got this integer, it's green, it's 10, and that's all fine and dandy. But then I do this, and green is now not 10. What value is it? Well, it's actually this. It's null. It's, as a programmer who's come through from C and Java, I look at this and I go, int green is null? Really? That's a thing? Well, turns out Dart's current, if you will, type hierarchy looks a bit like this. And by int here, I actually mean all the things, so strings or colors or whatever. But what we've got is object is a superclass, object has everything as a subclass of it, int has object as a superclass, and null as a subclass, and null is a subclass of absolutely everything. Which means that to actually, let's go back here. The problem we're having is we define that red, green, and blue take type int, and null is a subtype of int. So null is always, in this current type system, an acceptable value for an int or a string or anything really, because it's the bottom type. It's the subtype of absolutely everything. But we don't want that. Obviously, by the code we've written, we want to be able to define a type that is int without null. So we need to actually change the type system. We need to break this type system. And how do we break it? We take away null as a subtype of int. Okay, where does that leave us? What we can do is mirror or sort of completely duplicate the type system. So now we have nullable object, a non-null object. We have nullable int, a non-null int. And we have null as a subtype of every nullable type. Well, that's interesting. We've got two type hierarchies that are completely disjoint. That's not what we want. We want one type hierarchy. So how do we do that? We make object a subtype of nullable object, int a subtype of nullable int, which means if we want to, we can turn around and say, let's have a nullable int. To that, I can pass either an int or a null. And that means that I can turn around and have these things like my favorite color in person, where we go, I don't know if this person has a favorite or not. So null is a perfectly viable and valid choice. Alternatively, there are places where I don't want nulls, e.g. the color components. For those, I use a non-nullable type. suddenly I can start specifying what my null preferences are. But if you look at this type hierarchy, there's a great synergy, there's great symmetry here. We've got a top type in nullable object, but now because null is not a subtype of every type, it's not the bottom type. There has to be another type for this whole hierarchy to have a top type and a bottom type and to actually make sense on a type basis. So Dart introduces a new type called never. This is sort of null without null. So it's the type that has no values. Like null is a value that has no information, but it's still an object. Whereas never is a type of things that never happen. Or we'll get into it. I'll show you an example of where never is useful in a little bit. So let's do that again. I'll just break out of presenting and bring in this other cake that I cooked earlier. Yep, it's the right one. And let's do this again. Yep. So as we said before, we're going to have a color. It's going to have 3 components, red, green, and blue. And we're going to turn around and say that it has 3. What's this red squiggle going on here? So this is the first point where we move away from our previous script. Suddenly this is saying the parameter red can't have the value of null because of its type. It's non-nullable, remember. Down here, there's no question mark. So it must either provide a default value or a required modifier. Now, because I don't have a sane default value for red, green, and blue, I'll just turn around and mark it up as having required. Okay, let's go a bit further. And just to step back a step, remember in the previous run through how we had a whole bunch of asserts and we had values that we were copying around and all sorts of fun and games? This is the equivalent of that code. This to when running under, as you can see, once we run the enable the experiment to run non-nullable, this will turn around and enforce at runtime, or actually enforce it at compile time, that all 3 of these components are non-null. Okay, let's dive on. A person, have a color. I'm now going to introduce the question mark. So remember when we were defining person, we weren't sure if they had a favorite color or not. So by adding the question mark, we're saying null is a valid and viable type for favorite, for person, their favorite color. We may not know what it is. They may not have a favorite color, and that's fine. There's actually nothing wrong with null. You just have to be aware of where it is. And that's the whole point of null safety, making what was previously implicit and kind of frequently forgotten explicit and obvious. Okay, let's drive on. So now I've got a toString, person with favorite color, and then we have this, and we turn around and run it. And you can see we've got the same problem. So we know how to fix this. We turn around and add hex. We add an encoder and a string getter, and my dog is snoring in the background. And here's the next part. We've got this favorite that's turning around and it's potentially null. And so what it's saying is you can't call the hex getter on this potentially null value. You must do something with it. Okay. Let's turn around and do a null check. That makes sense. And it's complaining and saying it still could potentially be null, but I've just done this null check. What? Well, there's a way around this. There's an easy way. We'll just add a bang. There we go. We're asserting at runtime. This is going to be, oh, sorry. We're asserting here at compilation time that this is going to be non-null. Dart has gone, there are circumstances this is not true, so I'll insert a runtime check. So it's going to insert some code at runtime that will throw an exception if favorite is null. Fair enough. But, you know, it now compiles and runs. So I can run this, and we can see that I'm a person with a favorite color of sort of this greenish blue or bluish green. Yeah, cool. I'm curious about this. Why is that required? Well, if I put on my hat where I turn around and break things, I can take it a step further. Let's turn around and, you know, anytime you're going to break something, importing math so that you can have random numbers is a perfectly legitimate way of doing it. So what have I done? I've created a rainbow person who extends person. They have a random number generator, and their favorite color is a set of random ints. And occasionally, if rand is equal to 3, rand next into 5 is 3, then I don't return anything. So I'm taking full advantage of this optional color and sometimes returning null. So let's see what happens. I should probably make myself a rainbow person. Cool. Let's run it. I have no favorite color. Oh, that happened quicker than I was expecting. So here's a stack trace. Why am I getting a stack trace? I've got this null check, and then I print out this favorite. This isn't getting the this piece of data, but in the overridden version, I've put this getter here that returns a random color each time it is called. This is non-constant, which is why this bang operator is required, because this call to favorite and this call to favorite can return different values. And what's happened here is that on this call to favorite, I've got a color that's not null. And then when I've gone to call.hex on it, I've gone back to rainbow person's favorite color, and it's now null. And so, of course, I get an exception stack trace. So what's the correct way to handle this? Well, if I turn around and cache the color, and then I can do favorite equals null, and suddenly I don't need the bang, because Dart can do the data flow analysis and turn around and it can prove at compilation time that this favorite, even though it's got a question mark here, it knows by here, because of this check, it's no longer null. And I can safely call hex on it, and nothing bad will happen, because we've turned this ever-changing favorite color into a constant one for the length of this function by caching it. Okay, that's cool. We can now safely run the code, and you can see I have constantly changing color preferences, but it doesn't break. We're not throwing stack traces. So coming back to a theme that I've got here, nulls aren't a problem. Assuming something is non-null at all times is a problem. So be careful of bang operators, not nulls themselves. Use nulls where they make sense. And obviously for this person, the way we've decided to model colors or model people as potentially having favorite colors, null is a perfectly valid option. Okay, let's take this forward. So I'm going to give myself a constant color again. We'll get rid of the rainbow person, and we'll get rid of rand. Okay. What next? Well, let's think about something else. What if instead of having potentially no color, what we're interested in is defining at runtime the fact that we have a favorite color. We always have a favorite color. We just don't necessarily know it when we instantiate the person. Maybe it comes later. Maybe it's the result of some computation. So what we're going to do here is we're enforcing in the toString method the fact that the favorite is not null, and we can print out the color if they do. Then we'll throw an exception and say, hey guys, person must have a favorite color. Wouldn't it be nice if I could pull this code out and put it somewhere else? Well, let's do that. Throw a custom exception. I know I haven't actually defined a custom exception, but this is broken. If we go back a step, here the data flow analysis is working. It knows that this favorite color cache is not null. Why is moving it down here breaking everything? Well, the trick here is that this void is equivalent to null. So what we're saying here is this may return nulls. So if instead we say never, like we're effectively saying this method will never return any values. It will always abort. And in this case, that's quite true. I always throw an exception. Now suddenly, the value of this never type actually makes sense, because the data flow, seeing that if favorite is null, we get to this, and this always aborts because the type system says never, it never returns. Suddenly, fave.hex is safe to do. We know that fave is never null. Cool. But this, that was a useful sprint sideways just to show what happens with never, but there's actually a deeper pattern here. The pattern I'm getting to here is that I know at some point I will define what the favorite color is. I just don't know it at personal initialization. And Dart actually in null safe is introducing a way of saying to the users, I will get around to defining what my favorite color is. And that is late. So suddenly I've dropped the question mark and said late color. Actually, I should just, before I get that far, might as well just run this and confirm everything works. Yep, I'm back to my bluish green. So now that we introduce late, we now know that color is, it's not null. We're defining as not null, but we're saying with the addition of the late keyword, we won't know it at the initialization of person what that favorite color is. So suddenly now we're getting a warning from the editor saying that you don't need to null check this. We know that this is not going to be null by the time you get here. Well, moreover, what's really happening is we're saying to the runtime, we believe it will never be null, but check us. So we can turn around and get rid of, just to point it out, we're going to get rid of this caching and all this check, where because we're effectively saying the design is the person will always have a color instantiated on them at some point before we turn around and print them out. So we simplified a bunch of code. And if we turn around and, what did I do there? Oh yeah, I don't need that custom exception anymore. If I do actually turn around and create a person that doesn't have a favorite color, and I try to use this toString method, then I'm back in the land of having an ugly stack trace. But it's turning around and showing me you failed to initialize your favorite. So it's a much better place than before, where we just have this random, somewhere deep in the implementation, null pointer exception. This is quite explicit. It's turning around saying, you told me that you would initialize the favorite color and you didn't. So guess what? All over. So what we've done is taken a bunch of patterns that had to be implemented by hand slowly and methodically and turned around and made them quite explicit. So now we can see this color value object. It always has red, green, and blue. That's enforced by the compiler. This person will get a color at some point. That's enforced by the runtime. So there's a bunch of things here that we've been doing in a roundabout way that now have explicit export support in the programming language. So let's get back to the deck. So a quick recap of what I've just shown you. We take our good old friend Green. Mr. Green has a value of 10. If I turn around and try and assign null, that's an error. It'll be caught at compilation time. If I turn around and don't assign anything, that's also a compilation error. What I need to do is either say it's optional, or I'll get around to doing it later. And there is actually more that you can do here. You can turn around and give it an initializer. And this is Dart's way of saying lazy initialization. This is quite useful if you need to initialize part of a class, but do it with the presence of this pointer. If you turn around and make that late, at the point, the field will be initialized when it is first called, at which point this is a fully formed object, and you can turn around and pull the object apart and do your appropriate calculation to fill in the field. You can even go so far as to say late final. So this field will be set exactly once, and that will be enforced by the runtime, and it will be filled in, or again, you'll get an exception. So there's a bunch of common patterns that have been done in various long-winded ways that are now explicitly spelled out in the code. Just ripping through a couple of the operators, we have the bang operator that effectively inserts a null check with a throw an exception if it fails. We've got, of course, the question mark for being able to supply default values for potentially optional things. The null aware dot operator is actually a bit smarter than it used to be. Previously, the minute you introduced a question dot into an expression chain, you had to flow all the way along because it was just evaluating the expression of the part of the expression to null, so it would flow all the way through. Whereas now what it does is it short circuits. So if you have a deeply nested accessor thing where you do foo.bar dot of all the subcomponents, you only have to insert question dot where things are optional, anywhere, and if that is null, then the rest of the expression is short-circuited and you don't have to worry. Talked about required, and I need to point out, as should have been obvious from the command line, this is all currently experimental. This is a preview. We're getting to the point where we're going to ask all of you to start trying it out, kicking the tires, seeing if it works with your code, but this is not ready for production. Just saying. Oh yeah, tooling. It's always useful to have tooling. So if I go up here, get the right one, break out of presenting again, bring this down. What I can do is I can, somewhere up here, I can show off some tooling. So we've got this code. It's not null safe in any way, shape, or form. But if I turn around and run dart migrate, and I'm skipping over pub outdated and ignore errors because the project I'm in has a bunch of partially written code. And it will turn around and have a look at the project, found a bunch of stuff that was broken. But if I click on this and I drag this window down, I'll just hide my little thing. Now we can see what we have here is an in-browser tool that is turning around and showing us the code of our code, but it's turned around and gone, okay, these red, green, and blue fields, you're actually trying to make them non-null. So I'll just turn around and strip the @ signs. And this favorite, you're actually dealing with it as if it's null. So it's obviously optional. But when you get to here, we'll insert the bang. As we saw earlier, that's not a complete solution, but it's a quick solution. Also, amusingly, it's turned around and added a bang operator to this null to make all the types work. This is obviously a tool is not meant to do all the work of porting, but it gets you to the point where you have code that compiles and you can start looking at it and going, okay, and just to point it out, you can turn around and add hints and go, actually, where you thought that's optional, actually, I want that to be non-optional. So there's a bunch of hints you can turn around and give to the tooling so that it runs correctly. But realistically, you're probably going to run this tool and then go through and do a cleanup run and do some refactoring once you actually have the power of null safety. Like I get rid of these asserts once you turn around and make these non-null, because you don't need to assert them as not null. But so this is some of the tooling that will be coming your way shortly for you to start playing with null safety. Okay, back to presenting. Of course, the most important thing, we've got a whole bunch of documentation, and thank you very much.